Imagine if, for exactly 1 second, gravity just vanished. Hollywood often portrays this as a moment of total chaos, with people in cars suddenly ripping off the pavement and shooting violently toward the stars. But physics suggests a different reality. Gravity provides a constant downward acceleration of 9.8 meters per second squared. Removing it simply leaves you with your current speed. You would instantly become weightless, drifting only if you were already moving. The weightless second itself is a prelude. The primary destruction comes from the planetary shockwave triggered when the universe abruptly turns the force back on. As the 1 second window begins, the entire planet experiences simultaneous weightlessness. Humans and unanchored objects wouldn't fly away. Instead, you would feel a sudden, absolute release of pressure, a sensation of floating as you stop accelerating toward the Earth's center. Our atmosphere reacts much more aggressively. No longer compressed against the surface by gravity, the lower air begins to expand rapidly outward into space. On the ground, this creates a momentary extreme drop in air pressure. Your ears would pop instantly, followed by a sudden, eerie stillness as the atmosphere thins around you. Even the moon is affected. Without Earth's inward pull to maintain its curve, the moon drifts in a perfectly straight line for 1 second, moving slightly further into the void. In a single tick of the clock, the pressure and orbital equilibrium holding our world together are broken. At 1.01 seconds, the pause ends. The planet's downward pull violently snaps back. Everything that drifted even a few millimeters upward during that second slams back to the surface simultaneously. Despite the tiny fall distance, this simultaneous mass impact generates massive force. It's enough to shatter rigid bridge spans, crack foundations, and collapse delicate architecture across the globe. The Earth's solid body suffers too. Having briefly decompressed, the crust and mantle are suddenly crushed back into their original states. This internal jolt forces the planet's structure to instantly readjust to the returning weight. In geologically sensitive zones, this sudden compression triggers a spike in seismic activity, potentially leading to earthquakes and volcanic events as the tectonic plates reset. By simply pausing gravity for a single second, the Earth's own immense mass becomes a destructive weapon upon its return. Once the shaking stops, the mechanics of our planet carry permanent marks. The atmosphere never fully recovers. A small fraction of our air expanded too far during the lapse and is lost to the vacuum forever. The moon's 1 second straight-line drift has permanently altered its trajectory, locking it into a new, slightly larger orbit. This shift subtly but permanently weakens the ocean tides, a change that will persist for the rest of Earth's history. Of course, gravity cannot be toggled like a light switch. It is fundamentally different from forces like magnetism or electricity. General Relativity explains that gravity is actually the physical curving of space-time itself, warped by massive objects like our planet. To turn off gravity, you'd have to physically unbend the geometry of the universe, forcing the fabric of space to snap perfectly flat. If the force that keeps us grounded is actually just the shape of the space we occupy, it suggests our reality is more dependent on geometry than we realize. What would happen if the universe decided to change its shape again?